6, 7 minutes or so. And let's have you guys try A, B, C, and D. You're looking at the graph of the derivative, and then you are using that to answer A, B, C, and D using the graph of the derivative. Okay, go. We ready or we need more time? More time, you got it. Okay, here we go. First one, we're looking for a relative extrema, and we are looking for a justification. Hermela, what do we got? How about Caleb? How about Jessica? Am I on mute? What is going on here? You guys there? Somebody?
Yeah, I can hear you, Mr. Baker.
Okay, yeah. Somebody that's alive, tell me what's going on here, part A.
It's relative extrema. So there's a relative minimum at x equals 0 because f of x changes from decreasing to increasing.
Relative minimum at, what'd you say? There's
X
definitely
equals 0.
Is it at 0? Remember, it's the graph of the derivative.
Oh, right.
It is a minimum in the graph, but where is it? Remember, the minimum has to be at a critical point where it crosses, right?
Okay, I always get this confused between that and points of inflection.
Gotcha. Yeah, the thing you described was the point of inflection. Okay. So relative extrema would be where, Bennett?
It would be at x equals 2.
All right, so let's start with that. At x equals 2. So now we got our first point. Now we want to justify it. What's my justify? Because what?
F prime of x changes from negative to positive.
Because f prime of x changes from negative to positive. All right, good. All right, now points of inflection is what he started to describe. So that one's going to be the turning point of your derivative. So that one is at x equals 0 because f prime of x changes from decreasing to increasing. Okay. All right, last one, or part C, is two things at once. We want decreasing and concave up. Cade, you there?
Yep.
All right, what we got?
So I said that it's decreasing and concave up from 0 to 2.
Good. And because f prime of x is, we need two keywords now.
Both negative and increasing.
Good. Negative and increasing. Okay, so A, B, and C all kind of go together. That was stuff from prior in the year. Do we have any questions, guys, on A, B, C? Okay, so then with that in mind, we want to tackle part D. Leela, we there?
Yeah, can you hear me?
I can hear you. So what are we doing?
So you have to find the equation that you need. So it's going to be the integral of 4 and then -2 is at the bottom. And then of f prime of x dx is equal to f of 4 minus f of -2.
Got it. All right, we got the setup, and now we're trying to find f of -2. So how do we rearrange this so it's in order to do that?
Oh, do you want me to do it?
Sure.
Okay. You want to move the f of -2 to the other side
So
and move the integral to the other side. Yeah.
So that would be f of -2 is equal to f of 4. But now at this point, hopefully we can make the substitution that f of 4 is 6. So that's going to be 6. And then when you bring this one over, it's minus the integral from -2 to 4 f prime of x dx. Okay, cool. We got all of that. And then the last thing we need to find, we need an answer for what I'm putting a dashed box around. We need to go figure out the integral of f prime of x dx from -2 to 4. We want everything on here. So what have we got, Leela? What's happening?
So first you have a half circle.
Okay, we got a half circle, so that's that part. So let's just tackle that. What's the area of that shaded region? How do we find it?
It's gonna be pi r squared, but then you divide the answer by 2.
Okay, so this part's for the circle area.
Negative.
Pi
Yeah.
r squared over 2. And correct. When you're done, we're going to put a negative sign in front of it. Up to you if you were including that in the formula or whatnot. What's the radius?
The radius is 2.
Okay, so what did that give me for a final thing here?
2 pi over 2. Oh, would it just be? No, it'd just be 2 pi.
2
Sorry.
pi, because yeah, 2 squared is 4, so 4 pi over 2, also
Mhm.
known as 2 pi.
Yeah, but it's negative because it's under the.
I agree. So it's negative because it's underneath. So we got 2 pi. So we got to be careful. We don't put a negative sign there. That's just the dash. All right. So 2 pi and negative because it's underneath. Okay. And next, what do we need?
You need to find the area of the triangle, which is the, you just take the two sides, divide them by 2. So it's 2 and 2, it's 4. 4 divided by 2 is 2.
All right. So now we want to be careful how we express this combined area. Does it make sense? You can call it a couple things. You can say it's -2 pi plus 2. Nothing wrong with that. You could also say that it's 2 minus 2 pi, whichever way you want, but some combination of that is what represents the shaded area. Okay. So we're going to come down here, and what did you call it, Leela? What version of this?
I said 2 minus 2 pi.
2 minus 2 pi. Now be careful, make sure we put this in parentheses, because when you subtract a quantity, you got to distribute through. So this is really 6 minus 2 plus 2 pi, because minus minus when you distribute that negative. Anyways, the answer we're looking for here is that f of -2 is equal to 4 plus 2 pi. Any questions? Does that make sense?
Mr. Baker,
Yes.
if so, like on I guess we don't have tests like in your class anymore, but on the AP exam, if they give us a graph like that, are we like, if it just is like a half circle like that, but it doesn't say anything, should we just assume that it's some sort of shape?
Yeah, you can make that assumption, and I'm kind of cutting through all the writing just because I can't write all this out for you, but typically free response problems come with like a paragraph of gibberish with all kinds of details and stuff in it. And somewhere in that paragraph, it would make note that from -2 to 2 is a half circle.
Okay.
But yeah, in general, if it looks like something, it is.
Thank you.
Mhm. Okay, any other questions on that problem?
If you made pi like 3.14 and your answer was just like one number, would that count as like an answer choice, or would you want it to include pi?
You want to leave pi in your answers when it is on the free response. So yeah, just keep it like that. You're good to go. Okay. All right, guys, give me 1 second. Let me open up the folder here and get something else out. Let's see. Okay, so we're gonna do a couple problems here. So, all right, before I pull that one up, let's talk about the following. All right, so remember how I was talking about derivatives and integrals? They go forwards, they go backwards. So we want to look at the following situation. If I tell you that g of x is equal to the integral of f of x dx from, I don't know, x to 1 or something, whatever. Okay, if I tell you to find g prime, okay, g prime of x is equal to f of x. Does that make sense?
Yeah, I get it.
If you derive an integral, they wipe out. If you derive an integral, they wipe out. So you could also say the following. Anybody have any questions on that?
Wait, what do you mean by they wipe out?
Like when I take the derivative of this, it's g prime. When I take the derivative of this, the derivative of an integral wipes out.
So it like cancels, is that what you
Yeah,
mean?
disappears, cancels, left with what's in there. So here's where this becomes important. And this scenario will definitely 100% pop up more than once on the AP exam. And that's not a big deal because this isn't too bad. But let's look now at, no, that's not it. Let me try again. Let's see. There we go. Okay, so let's take a look at this problem. The graph of the function f is shown above. It's a little blurry, so we'll have to read through. Okay, the graph of the function f is shown above, and it has horizontal tangents at 2 and 5. Well, that's easy enough to figure out. Yeah. Let g be defined by the function given by, and then what you see there is, let me copy it for you. It's the function they tell you is g of x is equal to the integral from 0 to x of f of t dt. All right, now you're going to see this scenario a lot, them using these t's and dt's in this problem. All right, what does the value, or for what values of x does the graph of g have a point of inflection? All right, let's just back up a second here and forget about this side of the problem. We don't see it anymore. If I just say I'm talking about g, the question says, where does g have a point of inflection? Okay, what graph have we been using all year to figure this information out? The graph of the what?
The second derivative?
Yeah, that's not wrong. The second derivative is algebraically how we find points of inflection and stuff with concavity. What graph have we been looking at, though, to pull this information out of?
Oh, the graph of f
Parabola?
prime.
The graph of f prime, the graph of the derivative, right? And a second ago, we just did one like that. Where is the point or points of inflection in a derivative graph?
The turning points like in here in 2 and 5.
Okay, the turning points of a derivative graph, the turning points of a derivative graph is where you have points of inflection. So with that said, look what we can do. If I want the derivative graph, remember the answer to this question is about where does G have a point of inflection. That means if I could figure out the derivative graph of G, I just need to look for turning points. So let's see if we can make a comparison. G prime of X is equal to what happens when I derive an integral. It wipes out, and then I need to add one little more thing to it. It wipes out, and you plug the X bound in. Seems minor, it kind of is. And all of a sudden, I have that. G prime is equal to, also known as the same as, F. What graph am I looking at?
The fx.
F of X graph, also known as the graph of
The derivative.
Derivative of
G prime's graph, right? So if
Yeah.
I know, hey, the graph I'm looking at is G prime, and it asks me, where does G have a point of inflection? This problem just became really easy. Where are they at?
2 and 5.
That's it. So who wants to talk about that again? Or are we okay?
I get it, but like it kind of just gave you the answer at the beginning though, didn't it?
Yes and no, because it said it had horizontal tangents. Horizontal tangents are only points of inflection if you identify the graph that you're looking at to be the derivative. Right? So like once you realize you've got the derivative graph, then we're in good shape. But until then, could just be critical points or anything else. We don't really know. The big key is that you make the connection that I'm looking at the graph of the derivative.
Okay.
Okay. Any questions there, guys?
So how about the relative extreme? I was going to like, I mean, the first derivative is always for the relative extrema, and the second derivative is for point of inflections. I was going to take the slope of the this sort of parabola, or and that would be my point of not even inflection, but relative extrema. Shouldn't you derive it one more time, the gx?
No, hang on. So you're getting carried away here. You're not wrong in what you're saying, but now let's think about what we're saying. So what you're saying with that second derivative is necessary for POIs and concavity if we're doing algebra. If I tell you f of x is equal to 3x to the fourth minus 4x to the third, and I start telling you, okay, tell me the points of inflection stuff, tell me the concavity stuff, then that's when you get down to, all right, second derivative, set it to 0, factor stuff out, make your table, do your chart, whatever, get your answers. That's if you're doing actual longhand algebra. In this problem, we don't have any formulas, right? All we're working with is a graph. So think about every problem that I ever give you. If I tell you, all right, here's the graph of the derivative, and I tell you to find everything, tell me the relative max, tell me the relative min, tell me where it's increasing, tell me where it's decreasing, tell me the POI, tell me concave up, tell me concave down. You can tell me all of that stuff using the graph of the derivative, right?
Yeah.
So in the question we just had, it said instead of identifying it as the graph of the derivative, they said this is the graph of f of x, but the question says the following: G equals integral f. Tell us where G, doesn't say anything about f, tell us where G has a point of inflection. So if I could figure out that this is the graph of G prime, which it is, because G prime equals f by the little lesson we're having, if now I know, well, I don't care that this is f anymore. The important thing that I care about is that this is G prime. So if this is the graph of the derivative of G, and I want to know where does G have a point of inflection, in the problem we just did, that was at 2 and 5. Does that make sense?
Yeah.
So yeah, like a visual way of doing this is just the derivative graph tells me everything. The algebra way is, okay, now we need a second derivative, then you have to hammer it all out. Okay. All right, so let's see if we can find some more on that to talk about. Let's see. Yeah, here we go. Okay, can you guys see my screen?
Yes.
Okay, we're gonna have you do this entire problem on your own. This is a full-blown free response, a part A, B, C, and D. Things to look at. This is the graph of F. They tell you up front that G is equal to integral F. Okay, so for part A, it says find G of 5. What's that tell me to do, guys? Plug in what?
5.
Okay, so if I plug in 5 for G of 5, where's the bound at? It's getting plugged in where?
At the top of the integral.
So, and this is the graph of F. So would that make sense that now you're just using the graph of F to find -3 to 5?
Yeah, that makes sense.
Shapes, etc. Off you go. All right, part B. On what open interval contained in yeah, part B, easy. Part C, easy. Part D, you have some quotient rule stuff. You should be able to figure all this out. All right, you've got 10 minutes. At 4:15-ish, we will be going over this, and that'll be the end of class once we go over all that. So it'll take us to about 4:30. So you've got about 11, 12 minutes to see what you can do. Justify everything, see how many points you can get out of 9 on this, and we'll give you a score. Ready, go. Okay, guys, so let's see how we did. So, part A, find G of 5. So remember, free response, we want to rate stuff out. We want all the credit that we can get. So, part A, we should be saying G of 5, so lead with what you're working with. G of 5 is equal to -3 to 5 f of t dt. Okay, so now all we gotta do is go find it. So -3 to 5, all you need is an answer, and that's it. You've got credit. So -3 to 5, that's just the triangles up above. So make sure we keep track of our dimensions. So -3 to 5, that's a distance of 8. 8 by 4 is 32. Cut it in half. I'm coming up with 16 for part A. If you've got that and you wrote it out like that, that would be worth 2 points. So let's give yourself a score, see how you did. Okay.
I got that too.
Okay, so if you got it, give yourself 2 points and we'll look for a total score when you're done. All right, next. Part B. On what open interval contained in the graph is it both? It's important that you look at what it is. Is the graph of G both increasing and concave down? This is the same deal as what we just talked about a second ago. If you want to tell me stuff about G, we need to get to a point where we know that this is the graph of the derivative of G. And you also need to tell the College Board that you've made that conclusion. So the first point to this problem, and it's fine if you missed it right now, but this is where you learn. The first point to this problem is by explaining that you know G prime of X is equal to f of X, period, whatever, end of statement. We want to make that statement. G prime of X is f of X, because now we've told everybody, got it, this is the derivative graph. And then you can make your statements from there. So that's going to be worth 1 point. Next, we're going to give an answer. So where is the graph both increasing and concave down? Should be easy enough for you. Hopefully you've got 0 to 5. So the graph is increasing and concave down on 0 to 5. There's your second point. So this is 1 point for this one, 1 point for an answer, and 1 point for the justification. So you're more than welcome to do BC for because on these explanations with us. On the AP exam, you're rating words out. You're not abbreviating anything. What's my because? Because G prime equals f of X, that's my graph that I'm looking at, right? Is both what? Both positive and decreasing. Positive and decreasing on this interval. All right, so this part B is worth 3 points. We want to say, start off by saying that we know G prime is equal to F. We want to say 0 to 5, and then we want to justify what we've got. So you always have to write justifications. I don't know, Hermela, I would, no matter what, just to be safe. The test should say to justify, but we should, at least for our practice right now in class, we're always going to justify because it's anyone's guess what they're going to ask you to or not on the test when you actually take it. So there we go. Now it says justify. The ones on on the AP exam most likely are going to be saying to justify. Okay, so 3 points for that one. Score yourself accordingly. Yes.
I was kind of confused because so I was able to determine that graph was the graph of g prime of x,
Okay.
but I got confused because I figured out where it was positive, but then the concave down part, I figured that was part of the second derivative.
Yeah. So remember, when you have the graph of the derivative, remember you can find all 7 things. Remember how if you're looking at the graph of the derivative, concavity is just tracing the slopes.
Mhm.
So positive slope is concave up and negative slope is concave down.
Okay.
So that's just the same. Once you make the connection that it's the derivative graph, then it goes back to that same test question you've been looking at all year, where it's just, we can identify everything here. At 5, that's a max. Things that are above are increasing. Things that are below are decreasing.
Yeah.
It's a point of inflection. That's the turning point. And then positive slopes are concave up, negative slopes are concave down.
Okay, thank you.
Sure. Okay, part C. So I just kind of talked about that answer. So for part C, we would want to lead off with the same thing. Does it have a relative min? At what value does x have a relative maximum? We would start off with, since g prime of x equals f of x, or just make that same statement. The graph has a relative max at x equals 5, because I always just say g prime equals f. That to me just summarizes everything, but g prime of x, you could probably say g prime of x changes from positive to negative. The important part is you just identify g prime because it's asking you about g. So because g prime of x changes from positive to negative, I would guess that to be 2 points. So far we have 1, 2, 3, 4, 5, 6, 7 points out there. 1 point for saying g prime is f, 1 point for getting an answer / justification. Depends how they would score it. So give yourself a score there out of 2 points. And my guess is if you're missing points, it's probably just because you forgot g prime is equal to f, but now that we're learning it, it's going to make sense. You're going to do that from now on. Okay. Yeah, easy enough. So, all right, takes us to part D. All right, h is given by that. Find h prime of 5. So we should say h prime of x is equal to, hopefully, how do we find this derivative, guys?
Bottom derive the top derive the bottom, negative the top derive the bottom.
Quotient rule.
And bottom
Yeah,
square.
which you're mapping out for me. Yeah, so we need to do a quotient rule. So it's bottom derive the top minus the top derive the bottom over the bottom squared. Okay, and now into that, what are we doing? We are finding h prime of 5. So h prime of 5 is equal to, what do we got? 15. Next, g prime of 5. How do we find that?
G prime
Well,
is equal to f of x, so you can just find wherever f of x is equal to 5.
Okay, so let's say again what she just said, because I was correct. G prime, let me go scribble that off to the side here. G prime is equal to f. So g prime of 5 is the same thing as f of 5. So what is f of 5?
0.
0.
0. Okay. Minus, next, what do we want next? G of 5. Now, always keep an eye out in free response problems. You can save yourself time. They want G of 5 is the next part. What do we find in part A?
G of 5
It's already done. G of 5, right? Part A says find G of 5. That's exactly what we did in part A. The answer is 16. So there's oftentimes parts of these free responses you can just steal from your prior work. It's already done. So if you forgot about it, you'd have to go redo part A, but that's all you're doing to find G of 5. Okay. Times 3 divided by, what are we putting in here? 5. So 15 squared. Stop. You're done. Final answer. We don't want to do any more math. I don't care what the answer is. They will give you credit for that. As soon as you plug everything in, this is just like the trapezoid stuff. As long as you don't have any variables showing and it's just a math problem, just arithmetic, you're good. There's no need to risk a math mistake. If you did, you should be getting what? 0 minus 48. So you could keep going, but if you make a math error, they don't give you credit. You leave that, you've got credit. So if you did keep going, it's what? Negative 48 over 225. That looks like you could simplify more. What are they all divisible by? 3? Maybe
16 over 75.
Yeah, 16 over negative 16 over 75 looks like the best answer. Again, though, they would give you credit for this, for that, for that. They don't care. They're all good. So you might as well just take the easy way out, which is as soon as you plug in everything, stop. Questions?
How did you get the 0
That
again?
one?
Yeah.
Okay. So we're looking for G prime of 5. Agreed?
Yeah.
Okay, so we need to make the connection. G prime is equal to F. So G prime of 5 is equal to F of 5. So I've got the graph of F. F of 5 is just the Y value that ties into 5.
Okay.
So this graph up top, it stands for 2 things. It's the graph of F of X. It's also the graph of G prime of X. Depending on what you want to use it for, they mean the same thing though.
Okay.
Make sense?
Yeah, that's what
Okay.
more sense.
Other questions? Anything, guys? Okay, that's all good stuff. So we'll keep practicing. We'll keep moving along. We'll keep learning. Today is Thursday, so it's not posted yet. I will message you on Remind when it is. Let me see what's on this test. Let's see. Is this doable for us? Yes, yes, yes.
Yeah.
Yes. We'd have trouble with that. Gene jogs, we can do that. Yeah, yes. We can do most of this test. Let's see. Yep. You're going to struggle a little bit with the free response, but yeah. Okay, there's going to be a couple areas in here where you have a little bit of difficulty, but like 90% of this totally doable. So I'm going to post this exam over the weekend, redo this question, try to do it on your own without looking. I will post this over the weekend. So it's about 10, 11 pages. This is truly about 90 minutes to 2 hours worth of calculus. So honestly, guys, you need to do this. There's no way around it. I can teach you and teach you and teach you, but the only thing that's truly going to get you through the AP exam is that you guys practice it and then apply it and get better at it. So today is Thursday. So you have Thursday, Friday, Saturday, Sunday, Monday morning, whatever. So sometime before Monday at 3:30, you need to spend 90 minutes to 2 hours going through this test, trying your best, seeing what you know. How much have we learned? I can give you an idea. Let's see, I can share my screen with you. All right, check it out. Here's my folder of stuff. So prior to school ending, or prior to you guys being kicked out, you guys did everything in my units 1, 2, 3, 4, 5, 6 folder, which sounds like a lot. It is. Unit 7 just goes from January to May. So if you look at that folder, here's the gigantic list of things. You are currently playing around with this one right here. You're right there is the file you're looking at right now. So we've tackled everything up above it. We need to still get through, not to scare the heck out of anybody, but we still need to get through all of these files. So you can kind of see when I opened them before, 215, 215, 31. You can kind of see over the years when they were used. So we need to get through every single one of these files. And then after we're done with that, we need to, where's that other file that I have? We got to do. You need to, I don't know where it's at, but then there's another folder with about 15 things in it. So yeah, we got lots to do. Lots to do. We'll get there, I promise. Just keep coming. I'll get you guys there. So we're moving along at a pretty good pace. We've made up a lot of ground, really. I was a little scared at first that we weren't going to get there. We're getting there. Keep coming. But the important part, though, is really and truly that you, between here and here, you do this work. Because I can teach and teach and teach, but it's never going to truly set in until you go do it on your own and figure out what did you understand and what did you not. So between here and here, you need to spend 2 hours doing that assignment. Bring it to me on Monday. Ask questions over the weekend. I'll help you. Send me a screenshot of whatever you're working on. I'm happy to help you. But you got to spend some time on this to work and see what made sense and what didn't. And then we'll keep on going next week. I just click on the next file every time I see you guys. So, okay, that's what I got for you. I will see you guys on Monday, and feel free to message me